In this video, I will debunk the absurd theories about the Przybylski star. The Przybylski star is an APA-type star, meaning that it spins really slow. And it has a strong magnetic field. What made this star famous is the fact that it contains a lot of heavy radioactive elements, such as plutonium and the lanthanides. Radioactive elements are known to decay after a while, turning into lighter, more stable elements. The half-life of plutonium is around 25,000 years, meaning that it takes 25,000 years for half of the plutonium you have to decay, and then another 25,000 years for half of what remains, over and over. This means that after about 100,000 years, most of the plutonium present would be already gone. This amount of time seems like a lot, but if we compare it to the life cycle of stars, we soon realize that it's actually a really small amount of time. The Przybylski star seems to ignore this. In fact, the plutonium reserves of this star are still high, and they don't seem to lower. This means that the star must have some ways to replenish its plutonium reserves as they decay. This is where the weird theories are created. Some scientists have suggested that an alien civilization may be using this star as a dumpster for radioactive waste. This theory explains both the high quantities of heavy elements and their replenishment, but it is heavily sci-fi-like and unlikely. This is why today I made this debunk video, in which I will show you three major more likely theories to explain the bizarre features of this star. The theories will be ordered from the most unlikely to the most likely. Let's begin. 1. The collision theory. This theory suggests that a rocky planet crashed into the Przybylski star not long before its discovery. Unlike gas giants, rocky planets contain the heaviest elements. We know for a fact that the Earth contains large amounts of uranium and plutonium in its crust only. Just imagine how much of it is found in the core. Basically, this theory says that the plutonium we detect today is the plutonium that was once stored in the rocky interior of this hypothetical planet, and the debris from this collision is still falling into the star today. Although unlikely, this theory explains each one of the mysteries that surround this star. 2. The large reserves theory. In order to bring this theory forward, we need to assume one thing. We need to assume that the nebula that generated the Przybylski star came from a neutron star collision. This is because heavy elements such as plutonium and the lanthanides are not found in normal star-forming nebulas, due to the fact that the heaviest element stars can fuse before dying is iron, while elements like plutonium can only be fused during kilonovas. After acknowledging this, we can move on to the theory. This theory suggests that the Przybylski star once had much more heavy elements than it has now, and that because of their quantity, they took a lot of time to decay. This means that what we detect now is a large but relatively small fraction of the radioactive material the star possessed, and it's still decaying now. Basically, the star wasn't replenishing its material. It simply had a lot of it from the beginning. 3. The protostar theory. This theory also assumes that the Przybylski star was born from a neutron star collision. This theory suggests that the star still has a protoplanetary disk, and as the system stabilizes, parts of this disk are still falling into the star. Both the star and the disk are thought to contain plutonium and other elements due to their common origin from a kilonova. This theory explains both the high quantities of heavy elements and their replenishment, and it's also really likely to be true, because we have already seen similar things in other stars. Thank you for watching.